Hello, Gregory here, and let's do the last part of complex numbers. Here we did adding complex numbers. Here we did subtracting complex numbers. So it makes sense that the next two things to learn are multiplying and dividing complex numbers. And the good news with this is if you're familiar with FOIL, multiplying complex numbers will be really easy because you just follow the rules for FOIL, which is first, outer, inner, last. And I don't really like the term FOIL that much. I prefer to think of it as you're doing the distributive property twice. First, you're doing the distributive property with the 5, then you're doing the distributive property with the 2i. So let's be careful as we do this. First, 5 times 3 is 15. 5 times negative 6i will be negative 30i. 2i, now we do the inside. 2i times 3 is 6i, positive. It's positive, so I write a plus sign. And here's the little different part. 2i times negative 6i is negative 12i squared. So 2i times 6i is 12i squared because of I times I. So let's simplify this a bit. You notice that these two combine. So 15, negative 30 plus 6 will be negative 24i. Now, what happens with this last thing? Remember that I squared is equal to negative 1. You really need to know that. So I squared is negative 1, and so negative 1 times negative 12, it just flips the sign. So that's something to get used to, but it's nice. Negative 12i squared, the I squared just flips it to plus 12 because this I squared piece is the same thing as negative 1. So you'll notice that I can actually combine 12 and 15. So this is 27 minus 24i, which is the final answer. So when you're foiling with complex numbers, notice that if they look like this, with a real and an imaginary and a real and an imaginary part, notice that the i's will combine, but you'll also have the real parts on the outsides combining as well. Just flip the sign if you ever have an I squared. So try to do this next one on your own. Pause the video, see if you can get it. All right, let's see if I can match your answer. We're just going to FOIL. 2 times 10 is 20. 2 times I is 2i. I times 10 is 10i. And I times I is I squared. So that was pretty easy. Everything was positive. 2i will combine with 12i. And remember, this I squared right here plus I squared is the same thing as minus 1. Okay, that's what this I squared is equal to. So 20 minus 1 is 19. 2i plus 10i is 12i. And there you go. Easy as that. 19 plus 12i is the answer. So just keep an eye out for these I squareds and turn them into negative 1s when you can. So something special is going to happen with this. We have 4 minus I times 4 plus I. Let's do it. Do our FOIL just like before. 4 times 4 is 16. 4 times I is 4i. Negative I times 4 is negative 4i, right? Negative I times 4 is just negative 4i. And the negative I times I is negative I squared. So something really nice happened. Do you see what it is? The 4i cancels with the negative 4i. You'll notice it's kind of like a difference of squares that you should have learned in your previous math class, 4 minus I times 4 plus I. Now, here we go, negative I squared. What should that become? Well, negative I squared should be plus 1, because I squared is negative 1, and two negatives make a positive. So the final answer is actually just 17, because 16 plus 1. So what do you notice about these two? They're conjugates of each other. The conjugate of 4 minus I is 4 plus I. So when we multiply a number times its conjugate, we don't have any more i's. We're going to use that later. Let's do this one. 2i times 5 plus 4i. This is just a distributive property one. It's not too bad. 2i times 5 is 10i. 2i times 4i will be 8i squared. This I squared becomes a negative 1. So that means this is negative 8. So we'll put it first. And there you go. So now let's simplify, let's do some dividing of complex numbers. And the rule here is we cannot have an I in the denominator of a fraction. That's the rule. And the reason is because, remember, I is a square root, and mathematicians don't consider it simplified, do not consider it simplified if a square root is in the denominator. So how do we get this I out of the denominator? What you do is you multiply by the conjugate. Because as we just discovered, if I multiply this by its conjugate, all of the i's fall away. So the conjugate of 5 plus I is 5 minus I. So I'm going to multiply the entire equation by a very fancy looking 1. Remember, this is just equal to 1, so I'm not changing the number. 5 minus I over 5 minus I is equal to 1. So let's do it. And as you get better at this, you won't need to show all of your work like I am. 4 times 5 is 20. 4 times negative I is negative 4I. Inside now, 4I times 5 is plus 20I. And then 4I times negative I is negative 4I squared. On the bottom, I have 5 plus I times 5 minus I, and we know we did this right if all of our I terms go away. So 5 times 5 is 25. And let's see, we've got 5 times negative I, which is negative 5I. I times 5, which is 5I. And I times negative I, which is negative I squared. So let's simplify this a little bit. Great news! Our negative 5i and our 5i cancel just like we wanted. And in fact, negative I squared is the same thing as plus 1. So that means on the bottom of our fraction, we just have the number 26, which is 25 plus 1. How about the top? Let's see, negative 4i squared is going to turn into positive 4. Hopefully this is making sense for you. I squared is negative 1, so this is positive 4. So on the top, I have 24 from 20 and 4. Now let's combine these two. I get 16i. And this is the answer, but we could still simplify it a little bit more. If you wrote this, I'd probably give you half credit. Let's think of the largest number that goes, well, actually, let's go ahead and break it up right now. So this will be 24 over 26 plus 16 over 26 with the I attached to it. And finally, let's just reduce these fractions. Let's see, 2 goes into both of those. I think that's the only number because 26 is 2 and 13. So divide top and bottom by 2. We get 12 over 13 plus. Same thing over here. I think 2 is the only number. So 8 over 13i. There's your final answer. So what's the point of what we just did? We just took a complex number, divided by a complex number, and got a complex number. 12 over 13 plus 8 over 13i. Let's do this last one. I want you to try to do it on your own. First, what is the conjugate that we're going to multiply by? You should multiply top and bottom by 3 plus 2i, because that's the conjugate of the denominator. We want to get the i's out of the bottom. So pause the video, try to get it on your own really fast. All right, let's do it. I'm going to go kind of fast to stay under 10 minutes. So here we go. This is going to be 8 times 3 is 24. 8 times 2i is 16i. 6i times 3 is 18i. 6i times 2i is positive 12i squared, which will turn negative. Down on the bottom, we have 3 times 3 is 9, plus 6i minus 6i, which is good because that cancels our i's. And then negative 2i times 2i is negative 4i squared. So these pieces cancel right there. 12i squared is the same thing as minus 12. Negative 4i squared is the same thing as plus 4. So let's simplify a little bit. We have 24 minus 12 on the top will be 12 plus, looks like 34i on the top. On the bottom, we have 9 plus 4, which is 13. So that's the answer, 12 plus 34 over 13. Let's break it up to make it a complex, to make it look better as a complex number. 12 over 13 is the real part. 34 over 13 is the imaginary part. And there you go. So We have a few more problems to do. They go really quick, so I'll just get them in part 4. I will see you there.